Okay, so we're going to do slippery slopes today, but we're not going to go to the first two pages. We're actually going to go to this page right here, which is page 45. Now, in the last lesson, we talked about Jack and Jill and went up the hill, and we did not use patty paper, but we did talk about it. And as we talked about it, we talked about the fact that it had a rate of change. We should say initially we had a proportional relationship, and that was right here. And then yes, we did draw triangles at x is 1, x is 3, and x is 6. We did do that. Now, this is a new graph. This is the graph of here. Now, it's wanting to know the first question. Just look at the pretty picture. Okay, first question. Is the slope positive or negative? Okay, so remember, when we're talking about slope, this direction is a positive slope, and this direction is a negative slope. So as the x's get bigger and the y's get bigger, you have a positive slope. If the x's are getting bigger but the y's are getting smaller, you have a negative slope. So as I look at this, this is getting larger. As the x get larger, the y's are getting larger. So that means that I have a positive slope. Okay? And for the explanation, I just told it to you. Examine the slope between A and B. Create a triangle. Okay, so we are going to do that. We are not going to trace it onto patty paper. We're going to label the triangle with the vertical and horizontal distances. Okay, and then we're not going to do labeling the patty paper, but we are going to come up with the slope of the line. So let's come up here, make it bigger so that we can see it. I'm actually going to pick a different color just so that it stands out a little bit. So I'm going to do this right here. So we are drawing this line. Now, it is going through 0, 0. That's a cool thing. So then I have, if I'm talking about the height of this right here, how far up it goes, I'm going to go up 1, 2, 3, 4, 5, 6, and I don't actually need that there, so I'm going to put the 6. Over here, I'm going over 1, 2, 3, 4, so I don't need to write that thing there. So 4. So in order to find that slope, remember when we're talking about slope, we're talking about height over the base. And again, remember, it's the change in y over the change in x. So when we're talking about that, the height or the change in y is 6. So down here, I'm going to write m is equal to 6 over, and the base or the x value, the change in x, is 4. Now, this is not simplified. We need to simplify that, and it would be this right here, 3 over 2. Now, didn't we already know that? Because right here it told you that it was going to be 3 over 2. Okay, so now we're not going to really follow everything here. So we're not going to do number 3 with rotating it because we didn't do that. We skipped that module, so we don't know how to do that. But the next part, number 4 on the next page, says create triangles with points B and C and then with B and D. So we're going to do B and C next. So I'm going to come here and I'm going to do B and C, and I make my right triangle just like I had in the past. So how far up does this go? Up 1, up 2, up 3. So that goes up 3. I don't know why I left that there. I don't need it. This goes over, oopsie daisy. Don't want to do that. Don't want to erase. Then it goes over 1, 2. I don't need that. That goes over 2. So again, When we're using this, we find the slope is again 3/2. Remember, the triangles are similar triangles. Triangles are similar triangles, so they're going to have the same proportion. Now, it wants B to C, or B to D, but I don't want to mess up all of what I wrote, so I'm just going to do it upside down. It's not a big deal. It's still a triangle. We still have a height. So we still go up 1, 2, 3, 4, 5, 6. Okay, gonna get rid of that. It's 6. We're gonna go over 1, 2, 3, 4. Get rid of that. And we have 4. So up here, we still are finding that it's 6/4, which is still 3/2. So all of these triangles are similar. First of all, they're all right triangles, and their sides are proportional. So we're going to go over to number 5. Okay, so we're going to skip this. We're going to go here. We actually did number 4, but we're going to come here to number 5. And it says, compare the triangles created on the line. How can you verify that the triangles are similar? So we have right triangles with proportional sides. Okay? Even though some of them were 3/2 and some of them were 6/4, those two are exactly the same numbers. Okay? One is just reduced and one is not. So, as we said, the slope of the line is 3/2. Now, we did get that. We could have gotten that straight from this equation right there. But we were trying to prove that that was true. Now, so that means in order for us to have the points be on the same line, that means that we have to have the same slope all the time. So we're going to go to 3,2 now. We're going to go to this one. Triangle slopes and the equation y equals mx plus b. And we did that in class already. So the first thing we always decide, remember, when we're talking about slope, is it positive or negative? Okay, again, this is a positive slope because as the x values, I should say, get bigger. That is not the word bigger. Bigger, the y values get bigger. Now, we're supposed to create 3 similar triangles. Now, you can create them wherever you want to create them, but it would be nice if they went through these, remember those little points right there? If they went through the little corners of the boxes, which are called lattice points. I know some of you don't like those words, but if you do that, it makes it so much simpler, so much simpler. So it looks like, oopsie daisy, it's going through right here and right here. So I could make a triangle right there. The height 2, the base 1. Now, could I have done this triangle right here and done the height is 4 and the base is 2? Could I have used, oh, I don't know, let's go with this point right here and this point right here. That's up 1, 2, 3, 4 and over 2. I could have used, I don't know, what color do I want to use? I'll use brown. How about this point up here and this point all the way down there? So that's 8 and that's over 4. Now, no matter which one you did, no matter which similar triangle you drew, the slope, we'll start with the brown just because that's the color I have right now. 8/4, that's the same thing as 2. The blue triangle, that's 4/2. That's the same thing as 2. We'll do the orange one. We have 4/2. Again, that's the same thing as 2. And the green, which green is it? That one. We have 2/1, which is 2. So every single time I drew a triangle, they are similar triangles. They're right triangles with proportional sides. Okay, so hopefully you figured out that the slope is 2. Now it just says down here how many triangles could be formed in the graph on this line. How do you know? Guys, I could just make more and more and more triangles. You saw that I could use different points. I could overlap my triangles. It doesn't matter. So there would be infinite amount of triangles. So consider the graph shown, determine the slope of each line, and then use the triangles to justify that the slope is the same between 2 points. Okay, so here we go. So first of all, is it a positive slope or is it a negative slope? Okay, we're not finding the equation of the line. That's why I'm not worried about something, I don't know. So this slope is going to be negative, and this slope down here is going to be positive. Now, do I have to write that plus sign? No, I do not. So I'm actually going to take it away. I just wanted you to see it. So here we go. We're going to use, I'm going to use this color. So use similar triangles. Okay, so I'm going to draw a triangle here. And I went up 1, 2, 3, 4. I went over 2. So using this 4/2, that tells me the slope is going to be 2. How about negative? Isn't it supposed to be negative? It's going in the negative direction. Oh, I don't want that color. We'll do it pink. I'm going to do a big triangle. How about that? I'm going to use this point. Trying to decide where I want it to go to. And we'll use this point. It's okay, I went over those words, or those numbers, that's okay. So I went over 1, 2, 3, I'll do it up here. 1, 2, 3, 4, 5, 6, 7 times. And over here I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 14. But remember, my slope is negative. So that would be 14/2, which my slope is -7. How about you yell at me for not knowing how to divide? That would be really good. How about I knew what the answer was, so I wrote it in the denominator. Thank you for anybody who just corrected that. So it would be -2. Thank you very much, because I make mistakes. So my slope is -2. Let's come down to this one down here. Let's go orange. It's a positive slope. Oh, I'm going to do a big one. How about from here over to here? I just have to see it. There we go. From there to there. Well, I can't do that in my brain. 1, 2, 3, 4, 5. So let's get rid of that. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Get rid of that for a moment. So my slope is 5/10. So my slope is 1/2. Now I'm going to do it again just to make sure that I did it correctly. So I'm going to do here and here. So this goes up 2, this goes over 1, 2, 3, 4. So my slope is 2/4, which would get me 1/2. So my slope on this one is 1/2.